Now we come to tasting, smelling, and touching. Although vision and hearing are by far the most important human sensation, is surrounded by the four other senses also, each of which provides an essential avenue to better understanding of response to the world around us. Tasting. Taste is important not only because it allows us to enjoy the food we eat, but even more crucial because it leads us towards food that provide more energy, sugar for instance, and all away from foods that could be harmful. Many children are picky eaters for a reason. They are biologically predisposed to be very careful about what they eat. Together with the sense of smell, taste helps us maintain appetite, assess potential dangers such as the odor of a gas leak or a burning house, and avoid eating poisonous or spoiled food. Our ability to taste begins at the taste receptors of the tongue. The tongue detects six different taste sensations known respectively as sweet, salty, sour, bitter, piquancy that is spicy, and umami that is savory. Umami is the meaty taste associated with meats, cheeses, soy, seaweed, and mushrooms, and particularly found in monosodium glutamate (MSG), a popular flavor enhancer (ACADA). And our tongues are covered with taste buds, which are designed to sense chemicals in the mouth. Most taste buds are located in the top outer edges of the mouth and at the back of the throat. As we chew food, it dissolves and enters the taste buds, triggering nerve impulses that are transmitted to the brain. Human tongues are covered with 2000 to 10,000 taste buds, and each bud contains between 50 to 100 taste receptor cells. Taste buds are activated very quickly. A salty or sweet taste that touches a taste bud for even 1/10 of a second will trigger a neural impulse. On average, taste buds live for about 5 days, after which new taste buds are created to replace them. As we get older, however, the rate of creation decreases, making us less sensitive to taste. Smelling. As we breathe in through our nostrils, we inhale airborne chemical molecules which are detected by 10 million to 20 million receptor cells embedded in the olfactory membrane of the upper nasal passage. The olfactory receptor cells are topped with the tentacle-like protrusions that contain receptor proteins. When an odor receptor is stimulated, the membrane sends neural messages to the olfactory nerve of the brain. We have approximately 1,000 types of odor receptor cells, and it is estimated that we can detect 10,000 different odors. The receptors come in many different shapes and respond differently to each of them. Touching. The sense of touch is essential to human development. Infants thrive when they are cuddled and attended to, but if they are deprived of the human contact, they start crying. Touch communicates warmth, caring, and support, and is an essential part of the enjoyment we gain from our social interactions with close others. The skin, the largest organ in the body, is the sensory organ for touch. The skin contains a variety of nerve endings, combinations of which respond particularly to types of pressures and temperatures. When you touch different parts of the body, you will find that some areas are more ticklish while others areas respond to pain, cold, or heat. The thousand of nerve endings in the skin respond to four basic sensations: pressure, hot, cold, and pain. But only the sensation of pressure has its own specialized receptors. Other sensations are created by a combination of the other four. The skin is important not only in providing information about touch and temperature, but also in proprioception, the ability to sense the position and movement of our body parts. The ability to keep track of whether the body is moving is also provided by the vestibular system, a set of liquid-filled areas in the inner ear that monitors the head's position and movement, maintaining the body balance. What about experiencing pain? We do not enjoy it, but the experience of pain is how the body informs us that we are in danger. The burn when we touch a hot radiator and the sharp stab when we step on a nail needs us to change our behavior, preventing further damage to the body. People who cannot experience pain are in serious danger of damage from wounds that others with pain would quickly notice and attend to. The gate control theory of pain proposes that pain is determined by the operation of two types of nerve fibers in the spinal cord. One set of smaller nerve fibers carries pain from the body to the brain, whereas a second set of larger fibers is designed to stop or start, as a gate would, the flow of pain. It is for this reason that massaging an area when you feel pain may help alleviate it. The massage activates the large nerve fibers that block the pain signals of the small nerve fibers. Experiencing pain is a lot more complicated than simply responding to neural messages, however. Accuracy and inaccuracy in perception. The eyes, ears, nose, tongue, and skin sense the world around us and, in cases, perform preliminary information processing on the incoming data. But by and large, we do not experience sensation, we experience the outcome of perception, the total package that the brain puts together from the pieces it receives through our senses and that the brain creates for us to experience when we look out of the window at the view of a countryside or when we look at the face of a good friend. We don't just see a jumble of colors and shapes, we see instead an image of our countryside or an image of a friend. So, there are many more things that we can learn, like how the perceptual system interprets the environment. So, one of this sensory interaction, the working together of different senses to create experience. Sensory interaction is involved when taste, smell, and texture combine to create the flavor we experience in food. It is also involved when we enjoy a movie because of the way the images and the music work together. Then we have things like illusions. Although our perception is very accurate, it is not perfect. Illusions occur when the perceptual processes that normally help us correctly perceive the world around us are fooled by particular situations so that we can see something that does not exist. Many of things are called optical illusions too. But what are the important role of expectations in perception? Our emotions, mindset, expectations, and the context in which our sensations occur all have a profound influence on perception. People who are warned that they are about to taste something bad rate what they do taste more negatively than people who are told that the taste won't be so bad. And people perceive a child and other pair as looking more alike when they are told that the parent and child. Our perception are also influenced by our desires and motivations. When we are hungry, food related words tend to grab our attention more than non food related words. The psychology in everyday life in this chapter is how understanding sensation and perception can save lives. Human factors is the field of psychology that uses psychological knowledge, including the principles of sensation and perception, to improve the development of technology. Human factors has worked on a variety of projects ranging from nuclear reactor control centers and airplane cockpits to cell phones and websites. For instance, modern televisions and computer monitors were developed on the basis of the trichromatic color theory, using three color elements placed close enough together so that the colors are blended by the eye. Knowledge of the visual system also helped engineers create new kinds of display, such as those used on notebook, computers, and music players, and better understand how using cell phones while driving may contribute to automobile accidents. Psychologist Conrad Kraft hypothesized that as plane lands with no other distance cues visible, pilots may be subjected to a type of moon illusion, in which the city lights beyond the runway appear much larger on the retina than they really are, deceiving the pilot into landing too early. Kraft's finding caused airlines to institute new flight safety measures where copilots must call out to the altitude progressively during the descent, which has probably decreased the number of landing accidents. One important aspect of the redesign was sensory adaptation. Displays that are easy to see in darker conditions quickly become unreadable when the sun shines directly on them. It takes the pilot a relatively long time to adapt to the suddenly and much brighter display. Furthermore, perceptual contrast is important. The display cannot be so bright at night that the pilot is unable to see targets in the sky or in the land. Human factor psychologists use these principles to determine the appropriate stimulus intensity needed on these displays so that pilots would be able to read them accurately and quickly under a wide range of conditions. The psychologists accomplished this with developing an automatic control mechanism that senses the ambient light visible through the front cockpit windows and that detects the light falling on the display surface and then automatically adjusts the intensity of the display for the pilot. So this is how we use psychology for improving our everyday life. So this was all about chapter 4. For chapter 5, please stay connected and go through this video again and again. We will be soon back with the new chapter. So till then, take care. Bye-bye.